Good day, grade 11s and grade 12s. Welcome to this session on functions, which is one of the topics that you'll be examined on in paper 1. And functions carry a lot of marks. So it's very important for you to get the basics of functions as well as the core content of functions in order for you to be good with your functions. Okay, so I would advise you to check my sessions on introduction, where I was discussing terminology such as axis of symmetry, asymptotes, domain and range, as well as the notations that we use in functions. Okay, also do watch the session on straight line function as well as the other sessions on different types of functions that I've covered, okay, like your exponential function, your hyperbolic function, as well as your linear function, okay. So for this lesson, we'll be looking at your parabolic function, okay. It is also known as the parabola. If you don't want to say parabolic function, you also call it just parabola, or other textbooks they would say this is a quadratic function, okay, which all of these mean one and the same thing. Either you call it a parabolic function or a parabola or a quadratic function, okay. So also with your parabola, it's very important to note that your parabola may have this shape, which is a smiling face or a smile, right? And also your parabola may have this shape, okay, which is a third face. So your parabola will either look like that, which is a happy face or a smile, or your parabola may look like that, which is a sad face or just a sad person, okay. That is the that is how a parabola looks like, okay. That is the shape of the parabola. So when dealing with a parabola, it's very important to note that there is a point or a part in the function where the function is turning, okay. So it moves like that, and then somewhere here starts to turn, and then it goes all up, okay. Same applies to here, it moves like that, then somewhere here starts to turn, then comes down like that. So what do we call this point here, which is turning? We call that the turning point of a parabola, okay. So that's a turning point. So if your parabola is a smiling parabola, then that turning point will be called a minima or a minimum, okay. Also, if your parabola is a sad parabola, the turning point will be called a maxima or a maximum, okay. So this is very, very important, because most of the learners at times they don't know what we mean when we talk about a turning point. So a turning point of a parabola is those parts there, and it's very important for you to know when will it be a minimum and when will it be a maximum, okay. Next up, we want to look at what do we mean when we say a parabola may be cut symmetrically, okay. So parabolas will be symmetrical at the line of symmetry, okay. Let's talk about that. What's the line of symmetry? So we're just saying, if I have a smiling parabola and I were to draw just a vertical line cutting the parabola at the turning point, then I would have two equal parts, which is that part as well as this part, and they would look exactly the same, such that when I fold the two pieces, they would lie on top of each other, okay. So they form mirror images of each other, and you may even say they form duplicates of each other. That's fine, okay. Similarly, even if your parabola is a set parabola, okay, it will still form it's two identical pieces at the line of symmetry, okay. So the red line that you see here, is the line of symmetry, or what we normally call the axis of symmetry. Okay, so along the line of symmetry or the axis of symmetry, the parabola will be cut into identical pieces and they will form mirror images at that line. Okay, that is very, very important. So having said that, it means then if I have a parabola and I know the coordinates of the turning point of the parabola, I can be able to find the equation of this line of symmetry or the axis of symmetry. Okay, remember the axis of symmetry will cut the x-axis at the point 2 for this example, and as a result, this line, if drawn to scale, will be parallel to the y-axis. Okay, it will be parallel to the y-axis, and if it's parallel to the y-axis, then we know that the equation of this line will just be x equals to a constant value, and in this case it will be x equals to 2. Okay, so there we go. So the equation of the axis of symmetry, the red line here, for this case will be x equals to 2. Okay, and remember, x equals to 2 will be the equation of the axis of symmetry for this example, but do we have a general formula that we can use for all parabolas where we are determining the equation of the axis of symmetry? Yes, and this will be the equation that we will use for all parabolas when we are finding the equation of the axis of symmetry. So what does it mean? It means the equation of the axis of symmetry of a parabola will always be x equals to. Okay, so what is the formula? The formula will be minus b over 2a. But remember, we said the line of symmetry cuts the parabola at the turning point. So it means the equation of the axis of symmetry is given by the x value of the turning point of a parabola. Okay, so as you are calculating the equation of the axis of symmetry in this case, also note that your x is your x value is your turning point x coordinate. Okay, so after finding the equation of the axis of symmetry, that value that you will get from this will represent your x value of the turning point. Very, very important. Okay, now next up, I want us to look at an example where we are given that this is the parabola f. Okay, it's smiling. So what do we know? We know that this is point A, is given, this is point B, the turning point, and this is point C, the x-intercept. So A and C are the x-intercepts. And what conclusion can we draw from the axis of symmetry? If this is the axis of symmetry, then it means the distance from A up to B, this part here, will be equal to the distance from B to C, because this will be symmetrical. Okay, so as a result, also it's very important to note that the y values of A and C, since they are x-intercepts of this function, will be 0. The y values of A and C will be 0 because all values of y on the x-axis, okay, will be equals to 0. All the y values will be 0 on the x-axis, and I've noted it down there. On the x-axis, all y values are equals to 0, and that is why we normally call the x-axis the line y equals to 0, and we call the y-axis the line x equals to 0, because all x values on the y-axis will be 0. Okay, so now let's find the coordinates of C. That's what I wanted us to find. We know what is A. A is -1, 0, and then B is 2 -1. So we know only the y coordinate of C, which is 0, because C is the x-intercept and y will be 0. But we need to find the x-intercept of C. And how do we do that? Remember, your B will act as the midpoint of A and C. Okay, so if AB equals to BC from symmetry, okay, that we have operated or we've done, then it means, okay, by the way, I've already stated that the y coordinate of C will be 0, because on x-axis all y values are equal to 0. So if A equals to BC because of axis of symmetry, okay, or symmetrical cut, then it means the x-coordinate of A plus the x-coordinate of C all over 2 will be equal to the x-coordinate of the midpoint, which is B. And then substituting, we found that the x-coordinate of C is equal to 5, and therefore the coordinates of C would be 5 is to 0. Okay, we've used our midpoint. So that is the conclusion that we can draw from a parabola. Since a parabola is symmetrical along the line of symmetry or at the midpoint, then it means from one intercept to the midpoint and from the midpoint to another intercept will be equidistant. Okay, now let us check the properties that we need to master when we are talking about a parabola. Okay, a parabola, very, very important, will have the highest exponent of the variable being equal to 2. And that 2 tells us that every parabola will have at most 2 x-intercepts. Okay, maximum number of x-intercepts for a parabola will be 2. Okay, very, very important. And then when you minus a 1 from the exponent of from the highest exponent of the variable, which is 2, minus 1, I'm getting 1. So the answer that I'm getting 1 tells me about the number of turning points that I must get for a parabola. So how many possible turning points will a parabola have? A parabola can only have a maximum of 1 turning point. Okay, that is when we are dealing with a parabola. A parabola can only have a maximum of 1 turning point. Okay, so a parabola has 1 turning point. That is very, very important. 2 x-intercepts. And then last one is every parabola will have 1 y-cut or y-intercept. Okay, that's it. If it doesn't have the y-cut or the y-intercept, maybe the case would, I don't know, but we've never come across such a case. But all parabolas will have at least one y-cut or y-intercept. Okay, they have 1 y-cut or y-intercept. So those are the properties of a parabola. Okay, now remember I said to you every function has its own rule or formula or equation. Okay, so with a parabola we've got 3 forms of equations that we will use in order to find the equation of a parabola. So from the 3 forms of the equations of the parabola, we're gonna check from each one what are the conditions for you particularly to use that particular form of an equation. The first one that we have is called the standard form. Okay, so when we are dealing with the standard form would look something like that. Okay, that will be y equals to ax squared plus bx plus c. This is very, very important. So it has been written in such a manner that the exponents of the variables are decreasing. Okay, they are in decreasing order. It's 2, it's 1, then here we would have an x to the power of 0. Okay, so the exponents of the variables are decreasing. Now, since this is the standard form, let us talk about A, B, and C. Very important for you to know what they stand for. So your A in the standard form stands for the shape. So A is the one that tells you whether your parabola will be a smiling parabola or a sad parabola. Okay, and we will tell you how do you determine that. Then what about B? B tells you whether your parabola, your function, will lie more to the left-hand side of the Cartesian plane or more to the right of the Cartesian plane or to the y-axis. Okay, so if it's more to the left, you need to know when will that happen, and if it's more to the right of the x-axis, then you need to know when will that happen. Okay, that is very, very important. Now, also C stands for the y-cut, as in the straight line function or the linear function that we have done previously. And remember, C is also called the y-intercept of a function, where the function cuts the y-axis. Okay, now let us go into detail per variable. Okay, starting with A, we said A determines the shape of the parabola, whether it will smile or will frown. Okay, so if your A value is positive, your function smiles, your parabola will smile. Okay, and we say it is concave upward. Okay, as you can see, it's looking upward. And then if your A value is negative, then your parabola will be said, and this is normally said to be a concave downward. Okay, that is what A does. Now let's go to B. With B, remember we said it determines whether your function will lie more to the left or more to the right. We're talking about the x-axis movement. Okay, so if your B is positive, then your function will be more to the right. And remember, all x values to the right of the x-axis are positive. All right, hence we say when B is positive, then it means you are more to the right of the x-axis. And then when, okay, the other case that you may get is where, remember here A is positive and we see a smile, here A is negative and we see a frown, but we are also still at the more to the right hand side of the x-axis. Okay, then we may also get the case where B is negative. If the value of B is negative, what does that mean? It means our parabola will lie more to the left hand side of the x-axis. Okay, this is when A is positive, we see the smile, and then even if A is negative, for the fact that our parabola is more to the left hand side, that means our B is negative. And that is what B is all about. Okay, it determines which side will the parabola be more closer to. Okay, and then next up we look at C. Remember, what did I say about C? I said C is your y-cut, and this is where the parabola will cut the y-axis. Okay, hence I said this will be the value of C. Okay, and don't forget it is smiling, meaning A is positive, and since it's more to the right, we'll assume B is positive. Okay, so another thing that you need to know is when C is positive, okay, we are saying the y-cut will be above the x-axis. As you can see here, it's above the x-axis. Okay, very, very important. Now, what if C is negative? If C is negative, then it means our y-cut is below the x-axis and will be negative. Okay, since it's a set face, we'll assume that our A is negative, and since it's more to the right hand side, our B will be a positive. Okay, I hope you agree with me. Now our C is below the x-axis and is a negative value because all values of y there will be negative. Okay, that is what ABC stands for in the standard form. Now let's look at the conditions that you need to satisfy before you use the standard form of the equation of the parabola. So when dealing with the standard form of the parabola, you need to make sure that you know the value of C. Okay, you know your y-cut or your y-intercept. But knowing the y-intercept alone is not enough. So what you need two other points in order for you to find your A and your B. Okay, and then you'll be able to find the equation of the parabola. Now next up, we are looking at the second form of the equation of a parabola, which is called the turning point form. I think from the words itself, they explain that here it means this form needs you to have a turning point. Okay, so how does the turning point form looks like? The turning point form looks like that, which is y equals to A all multiplied by x minus p all squared plus q. Now, why do we say it's a turning point form? Very, very important. It's a turning point form because your p and your q in that equation, they represent your coordinates of the turning point. Okay, so it means when I take x minus p equated to 0 and solve for x, where x equals to p, then with your q together, they give me the coordinates of the turning point. Okay, so it means when your parabola equation is given in this form, already you can be able to immediately find your turning points. But in a case where you are given your standard form and they say you must find the turning points, okay, of the turning point of the parabola, then you can do that by using what we call completing the square. Okay, so when you complete the square, your standard form of the equation of the parabola, then it will bring you to this turning point form. Okay, also you can use the equation of the axis of symmetry, x equals to minus b over 2a. After finding the x coordinate of the turning point, substitute it into the original given equation in order for you to find the y coordinate of the turning point. Then you would have obtained your p and q, which are the coordinates of the turning point. Okay, also your a, like in the previous discussion, still determines the shape, whether your parabola will be a smiling parabola or will be a sad parabola. Okay, that is very, very important. Now, having said that, let us look at a. Take note, I've already spoken about a, where I said a, if a is positive, then it means it will be a smiling parabola. But what I'm interested in is, look at what happens when a is positive. The turning point is your minimum. It becomes the minimum, whereas the y cut, which is there, will be above the turning point, and therefore your y cut will be the maximum, where the turning point is the minimum. Okay, similarly, if your a is negative, what do you know about the shape of the graph? It will be a frowning graph. Okay, it will be a sad parabola. And what happens now with the turning point? The turning point now is up there at the highest, and we call this, we say the turning point is at the maximum. Okay, and then our y cut, remember, it will be there, and as a result it's below the turning point and it will be the minimum. Okay, very, very important. Note that b still functions the same way as in the standard form, where we said it tells you where your parabola will be, more to the left or more to the right. Okay, very important. Now let's look at the conditions that need to be satisfied for you to use the turning point form to determine the equation of a parabola. So these are the conditions. First of all, you must know the turning point of your parabola. It must be given to you. Okay, if you know it, then that's point number one. Second point, you need another point that lies on your parabola. So you need one other point that lies on the parabola, and that will help you to find the value of a. Okay, then you will then substitute the value of a back and simplify and find your equation in the standard form, okay, from the turning point form. Then, having said that, let us go to the last form of the equation of the parabola, which is called the intercept form. I think from the word itself, it's telling you that here you need to have your x-intercepts. Okay, by the way, this is the equation. This is the form of the equation of the parabola for the intercept form. Y equals to a multiplied by x minus x1, or multiplied by x minus x2. So what is x1 and x2 in these cases? Your x1 and your x2 are the x-intercepts. Okay, so it means when dealing with your intercept form, you need to know both your x-intercepts. Okay, not only that, you may also need to know one other point in order for you to find the value of a. Okay, so it's like I'm already giving you the conditions. So let's check. A still tells us about the shape of the parabola, whether it will smile or it will frown. So please check from the notes above. We've already discussed that. Okay, so conditions for intercept form, I think I've already said it. You need to know both your x-intercepts as well as one other point that lies on the function, your parabola, in order for you to be able to find the value of a. Okay, then we've come to the end of this session. Well done, and wishing you all the best with your mathematics, especially functions, because most learners, they are scared of functions. Functions are very, very easy. So please also watch my lesson on hyperbolic function, which is the one after this one. And also please subscribe, and I thank you very much for watching this session. Take good care and practice, and practice sharp.